All right, you guys, so this is going to be the nuclear YouTube worksheet. This is the pre-video place that is going to be some of that background knowledge that we've learned already in our class. So if you need to work with a teacher to fill that in as an absent student, please make sure that you check in with the teacher. The video is going to follow the majority of the worksheet. And then we have this as a class section. So this video is meant to be for our students who are absent to check in with the as a class portion and get the answers that they're supposed to have written in these blanks, and or for the students who have a teacher that's absent when we do this activity in the future. So this is a recap, kind of some information, and then there's some different things that we haven't necessarily talked about in depth here. So fusion is a nuclear reaction that happens in stars. That's where fusion occurs. It happens in stars because they have the high temperature and high pressure needed for fusion to be possible. So that core of the star, super, super warm, lots and lots of matter around it. The gravity of that is intense and it makes very, very high pressure situation. Fusion is when two or more nuclei combine, and it releases a lot of energy. Let me put that all in caps, a lot of energy. Okay, think about it, it's a star. That is what causes the energy that's coming from a star. All of the atoms found in our bodies and on our entire planet, except for hydrogen, were formed in stars. Fusion, creating elements up to iron. You can write iron or you can write Fe, either way. Then supernovas creating the rest. Now, I know in the video, they talked about how supernovas created elements all the way up to number 92. I would wager that if we can create elements all the way up to 118 in a laboratory, those elements are likely going to be created in a supernova as well. The problem is their lifespan is so short, they decay so quickly into smaller elements that we don't detect those anywhere in outer space naturally. So we can't really verify that a supernova has made them. So supernovas create the rest. We're just going to stick with that because if we can make it, I'm sure a supernova can make it. Okay, fission. Fission is another form of a nuclear reaction. Okay, so this is another form of nuclear reaction. This happens when radioactive elements decay. And we use the process for energy in nuclear power plants. We use the process for energy in nuclear power plants. Fission releases energy. Because when the nucleus of an atom splits, the two products have slightly less mass than the original nucleus. Slightly less mass than the original nucleus. The amount of energy can also be calculated using E equals mc squared. So that's the equation that we use when we're calculating the energy released in fusion, E equals mc squared, but it's also used to calculate the amount of energy released in fission. So both fusion and fission release energy, okay? Reactions that change the nucleus of an atom. Oops, I just spelled that wrong. The nucleus of an atom are nuclear reactions, okay? So nuclear reactions that change the nucleus of an atom. The two types are fusion and fission. The type that creates more energy is fusion. I hope that you think stars create more energy than power plants. So that might be an easy way to remember that, okay? So fusion creates more energy or releases more energy than fission does. And it's a lot more energy, okay? Okay, this color coding is definitely important that you get from this video or from class because we're trying to simplify the fusion and the element origin conversation. There are lots of different sources that have different information for this. We're trying to keep this very simple, sticking with our video, okay? So you need 3 different colors. And yes, even at home, you need 3 different colors. So find some colors, okay? So I'm gonna use red for my Big Bang. And so I'm gonna color in my Big Bang box red. I'm gonna use yellow for stellar fusion. And I'm gonna use blue or, I don't know, teal, whatever color this is, for supernova, okay? So color in your key with your 3 colors. Then we have to think about what elements we're talking about here, okay? So remember, after the Big Bang, almost all of the atoms that existed as atoms formed were hydrogen, but there was some helium as well, okay? So I'm gonna color hydrogen, don't color helium yet. So I'm gonna color hydrogen as a Big Bang element. All hydrogen was made in a Big Bang. You can't fuse anything to get hydrogen because hydrogen is the simplest thing. So that's definitely only red. But as fusion starts to happen in a star, we are mostly, for the majority of the life of a star, we are fusing 2 hydrogen atoms to make helium. So stellar fusion, stellar meaning in a star, that can also make helium. So Big Bang made some helium, stellar fusion made some helium, okay? Made probably more helium. So what I'm gonna do is I'm going to kind of do a little hash where I've got yellow. I'm gonna use yellow as my base color here. And then I'm gonna hash some red lines over it because helium was made in both the Big Bang and stellar fusion. So I'm making it both colors. Then fusion keeps happening and we make elements all the way up to iron. So remember, iron is our end point. So we're going to color all of those as stellar fusion because stars create all those elements. So the top 2 rows of my P block here are going to be stellar fusion. And then top 2 rows here underneath hydrogen, actually top 3 here. Hopefully that's showing up as yellow on your screen, okay? And then all the way over to iron, just iron, that's gonna be our end point. Okay, so there is my yellow section for stellar fusion. Then we get to our supernova, and a supernova is gonna be the rest, okay? So everything beyond iron in this periodic table. And again, I'm going everything, not just up to number 92, because if we can make elements in a lab, I am sure a supernova can make these elements as well. So while I'm coloring this in, I just want to point out this little side box over here by the answer key or the color coding key. And this is talking about the most stable nucleus on the entire periodic table. And that is the reason why stellar fusion ends with iron. Iron has the most stable nucleus of any element on the periodic table. So stars, even with their intense pressures and temperatures, they cannot make elements past iron because that nucleus is too stable. So you could switch back to your original writing utensil if you want, but the element that is the most stable on the periodic table, most stable nucleus, is going to be our iron. And that is why we switch to supernova for the creation of the rest of those elements. So hopefully that makes sense. Please ask your teacher if you have any questions and go ahead and submit pictures of this now that you are done with it. Thanks, guys. We'll see you in class.